Hi, I'm Arjun. I'm a rising sophomore at Saratoga High School, and this is my second milestone. For this milestone, what I'm doing is I'm using 4 flex sensors to control 2 servos and 2 DC motors. And to show you for a demo, this is how it looks like. When I bend the flex sensor, the servo will move, and the same thing with the servo will turn, and the same thing with the other servo like this. And with the DC motors, it's also the same thing as as you can see with, you probably can't see, but the DC motor turns when I do this, and the same with the other one. They'll both spin when I bend the flex sensor. And to demonstrate how this works, I need to split it into 2 sections. One would be the 2 servos, and the other would be the 2 DC motors. With the servos, it was relatively simple. There's 3 wires coming out from the servo, one for power, one for ground, and one for the digital pin on the Arduino. So I just had to plug it in and then simply code it to read the flex sensor's voltage, and based on that, map the voltage to match 0 through 180 degrees, so that the servo could turn however much it had to based on how far I was bending the flex sensor. But with the DC motors, it was a different story altogether because I had to use a motor driver, as you can see here. The motor driver made it a lot harder because there's not only one pin that you have to plug into the Arduino, but now there's 2, and they both have different purposes depending on the way you're using the motor. So the DC motors have 2 wires coming out, and these wires are plugged into the motor driver, which then sends 2 other wires down to the Arduino. But what happens is that I was actually stumped for a while because I was confused on why there were 2 when I'm only turning it in one direction. But after that, I realized that that's used if you want to do it for more complicated tasks later, and that's why for now I didn't use it. But with the motor driver, as you can see, there's 2 wires going to ground and power, and then one going. Well, there's 2 wires going to power, and that was actually one of the confusing things, because one goes to regular power on the Arduino, like it should, but the other actually goes to a battery pack. And that was something that was actually stumped me for a while, because when I originally had this running, the code was completely fine and the servos would turn, but the motors wouldn't, because they didn't have enough power to turn. And that's when I realized that I needed a 6-volt battery like the one I have here to actually power them on their own, because they take a lot more power than a servo does. And that's why, and after that, that's kind of when I realized what the purpose of the motor driver was, to actually, to connect to the battery pack and allow the DC motors to have enough power to turn on their own. And that leads me to the couple struggles I had. Like I said, one of them being that I didn't know I needed enough power coming from a battery pack to power it, and another being actually coding them. Because coding a servo was relatively simple. I just had to read the value from the flex sensor and then just map it to 0 through 180 degrees to turn the servo. But with the motors, I had to do that twice, and while the code seemed simple, the first time I was only doing it once and was confused why it wasn't turning, because I didn't realize that the 2 connections that I was talking about earlier, both of them had to turn. And after that, that was probably the most complicated challenge that I had to overcome. Now for the next milestone, what I'm going to be doing is actually separating this Arduino into 2. One with the 4 flex sensors and a button that I'll be adding, and the other with the 4 motors, and they'll be connected wirelessly using an NRF module, which I'm starting right now. Thank you for listening.